Ladies and gentlemen, you are welcome to this presentation entitled Comparison of the Performance of Hybrid Solar Gas Turbine in Atacama and Sahara Deserts. This work is done by myself, Daniel Sparparo, Luis Moran, and Bassem Belgasem. In typical hybrid solar gas turbine consists of three main parts: a heliostat, a solar receiver, and a gas turbine cycle. In typical hybrid solar gas turbine, air are first compressed using an axial compressor and then sent to the solar receiver where heat is absorbed by the compressed air. The compressed air are then returned back to the combustion chamber to reach the turbine inlet temperature. The exhaust gas are then expanded in the gas turbine section to produce electricity. The first hybrid solar gas turbine was installed in Almeria, in Spain. The capacity of the gas turbine is 4.6 megawatt electric, and the receiver is pressurized air receiver shaped as a cylinder. For more information about the operation experience of the first hybrid solar gas turbine, you can read more details in the publication given in this slide. This study aimed to investigate the influence of the geographical and climatic parameters on the performance of hybrid solar gas turbine with pressurized air receiver. For this reason, a number of sites located in South America, including Chile, Bolivia, and Peru, and North Africa, including Algeria and Libya, are considered. To investigate the hybrid solar gas turbine, practical technique is used to design the solar receiver for a 15 megawatt electric hybrid solar gas turbine. The layout and the optical efficiency of the heliostat field is carried out using solar pilot software, which is an open access software. The performance of the complete system is carried out using transit software. Figure 4 shows the layout of the heliostat field. The color bar gives the minimum, the maximum, and the average annual values of the optical efficiency of each heliostat. The annual average optical efficiency of the heliostat field in the selected seats, including Oruro, Antofagasta, Arequipa, BEHAR, and Sabha, are given in this figure. As you can see, in BEHAR, we get value above 56%. However, in Antofagasta, we get value below 48%. So the difference is important, and we can conclude that the optical efficiency of the solar field installed in Sahara deserts is better than a solar field installed in South America, in Atacama deserts. The design of the receiver is given in figure 6. As you can see in 3D view, the absorptive surface is circular and it is inserted into a cavity to reduce the energy losses by radiation and convection. The design parameters of the solar receiver are given in table 1. The nominal power of the receiver is above 135 megawatt thermal. Its absorptive surface is 300 square meter. The width of the apparatus is 8.8 meter and the height of the apparatus is 11.2 meter. The height of the tower is almost 200 meters. Figure 7 shows the heat flux on the operator of the solar receiver. The colored bars give the minimum, the maximum, and the average values. As you can see, the the heat flux on the operator is really high and exceed 1 megawatt per square meter. However, the area of the receiver is larger than the area of the operator. So we get just values below 400 kilowatt per square meter, which is acceptable. The modeling of the complete system is carried out in transit software in which various components including compressor, turbine, generator, receiver, combustion chamber, heliostat field, and weather data are linked together to build the model of the hybrid solar gas turbine. The results show the gas turbine efficiency, the gas turbine cycle efficiency is slightly higher in Atacama Desert than in Sahara Desert because of the average ambient air temperature, which is lower in Atacama than in Sahara Desert. However, solar electric efficiency of the gas turbine, of the hybrid solar gas turbine, is higher in Sahara Desert than in Atacama Desert. We get value above 19.5% for the case of BEHAR and Sabha. However, in Antofagasta, we get value around 17%, which is lower compared with values obtained in Sahara Desert. For the solar share, in Bashar and Sabha, and also Arequipa, we get value around 24%. However, in Antofagasta and Oruro, we get value relatively low. For the case of Antofagasta, the solar share is 11%, and for the case of Oruro, the solar share is around 16%. In this study, the performance of the hybrid solar gas turbine under Sahara and under some locations in Sahara and Atacama Desert are investigated. The optical efficiency of the heliostat field in Sahara is higher in Atacama, and the difference can be above 8 points, which is really important. The efficiency of the gas turbine cycle in Atacama is higher than in Sahara because of the average ambient temperature of the air. Solar to electric efficiency and solar share in Sahara are higher than in Atacama. This is because of the high optical efficiency and also of the annual solar radiation, which in some location in Sahara higher in some locations in Atacama. For further information, further work should focus on the economic assessment of hybrid solar gas turbine to calculate the levelized electricity cost. Finally, thank you so much for your attention, and for more information, please contact us by email.